Welcome to another video on Bayes' theorem. Bayes' theorem. Already done conditional probability, where said that one event gives information about the occurrence of the other. Now, in Bayes' theorem helps us to reverse conditional probability. That is, it allows us to find the probability of A given B, even if we know the probability of B given A. Also, the Bayes' theorem is useful in revising the original probability estimates of known outcomes as we gain additional information about these outcomes. The prior probabilities, when changed in light of new information, are called the revised or the posterior probability. What the Bayes' theorem does is, we know that if you celebrating your birthday or someone is celebrating the birthday, there will be cake. You get it? So the birthday cause the person to go and buy a cake. When you come to or when you go to any area or let's say any space and you go and meet a kid there, have a previous knowledge, you understand? You have a knowledge that it could be that someone is celebrating the birthday. That's why there's a cake on the table. Now you gather all your sorts of information and you realize that person is not celebrating the birthday. It could be that they bought the cake purposely to celebrate an anniversary or to congratulate someone on a milestone achieved. So there's a new information coming in. That's what updated your previous knowledge or previous info. You know that you or someone only buys a cake when the person is celebrating the birthday. So now, conditional probability, cause. So this is the cause, and this is the effect. That's for conditional. But in Bayes' theorem, you have the effect, and you are trying to determine the cause. And the formula for Bayes' theorem. We want to find probability of A given B is equal to probability of B given A times probability of A divided by probability. So this is basically what we want to find. This is what we want to find. That is the posterior probability. Then probability of B given A is what you already know. What you already know. This is what you already know. What you already know. Then probability of A is your initial belief. Your initial belief. That's what you already have there. Belief as a prior probability. Then the probability of B is your total probability. Total probability. That's the evidence you have in. All right. Now let's solve an illustration. The same vein. If you have this and you want to find this, now probability of in that A has occurred is A has occurred. Probability B divided by probability. So if basically there's a way of doing it because it reverses the conditional probability. Reverses the condition. So before we zoom into our illustration, All right, we know that for conditional probability, so probability of A, given that B has already occurred, probability, let's make probability of A that is in B. Probability of A in B times, let's make, also, we have probability of given A is probability of A, probability. We also want to make probability of times probability. What do you see here? That this or two can say that probability times probability of B. What I want to say, this theorem is simple. So if you have probability of A given B, and you're being asked to find probability of B given A, what do we do? Make probability of B given object. I want to make probability right through by probability of multiplied by divided by also if half probability of, you're being asked to find probability of probability times divided by, these ones are total, take note, they are total probabilities. What do we see? See, we have probability of A. If A has been reversed, right? And that's the trick. You're dealing with Bayes' theorem. Probability of, that's what we want to find. A, B, that's B, given A, or to reverse it. Probability of A, that's what we know, given B, times probability of what? Divided by probability of A. The same vein, if you have to find probability of A given B, you also reverse it. That's probability of B given A times probability of A divided by probability of